and welcome to this very practical session of handling unavailable backends. Again, with us we have Mathias Uhlmann speaking, and we also have, Viktor Sperling. Please join me in giving them a warm welcome, everyone.
Okay, so then hello once more. I think most people are the same like in the previous talk. Handling of temporarily unavailable backends. So this is something that's not just for OData V4, we also did it for OData V2, and there's a good reason for that. Let's first have a look at the agenda. So first I will say a few introductory words, explain the topic, the basic idea. Then Viktor will show to you what this could look like to you as a user if you're using one of our very technical test applications. So it doesn't look full Fiori style. And then Viktor will show to you what you need to do as a developer to use the feature. And finally, there will be time for Q&A. Okay, introduction. So, I mean, we all know all systems require maintenance activities. Yeah? That's there. SAP has invested heavily in the past to reduce downtimes, but even if you have something like zero downtime, there will still be maintenance activities that require downtime. So, for example, if you exchange the database, you cannot do this without a small downtime. The idea, and not our idea, we were just doing this then on the UI5 side, is to keep the downtime short, let the system be temporarily not available, and this means that all HTTP requests will then be replied to with status 503, so temporarily not available, and a retry after header. Now when we switch quickly to the user, yeah, so if you're an end user, you're working with an application, maybe you entered some data, and then suddenly your backend is unavailable. So if your application breaks because of that, that's really annoying. Yeah? You don't want to have that. So the idea is that actually on a deeper level of the OData model, we notice, okay, there is an issue with the backend, but it's temporary. Yeah? We see the 503 status, we see the retry after header, and we want to allow to repeat this request after the communicated time period. And this means that on this lower level, we decide to not fail. Yeah? We do not fail yet. Yeah, could fail, still fail later. We do not report the error, e.g., for example, to the message model. But instead, we provide the mean to the application to inform the end user about what's going on and to control the behavior. In the end, to allow the application to give the end user the control about what will happen. And what you will see now has been done by Fiori Elements V2 and V4. So if you're using Fiori Elements, you get this out of the box. You don't need to do anything. And it looks a bit nicer than in our technical demo. If you're having a freestyle application, then I think you could use what Viktor will show you now. Then, Viktor, please.
Thank you, Matthias. Also, hello from my side. I have the pleasure to showcase the feature Matthias has just described to you. Here we have a simple OData V4. It doesn't switch, okay. Here we have a simple OData V4 application with a corresponding V4 backend and a OData V4 model. Here we have the corresponding backend, and in this backend we have the simple report via which I can put this backend into maintenance mode, meaning the server will be temporarily unavailable. Now if I do this for 15 seconds, and go back into my application and refresh this list, this will send out a batch request, which will immediately fail with a 503 error. And you see a dialog indicating a progress bar. This will be retried after the given time. And voila, the retry happened and it was successful. If we look into the failed request, we can see the retry after header indicating the period of time, how long the backend will remain unavailable. And yeah, it's 10 seconds. I need time to switch between the windows, obviously. The same does also work for other kinds of requests. This was a GET request. If we, for instance, would do a post request. We have created an entry here on the client. If I would press the save button, it would persist, or it would send out a post request persisting this entry in the backend. Now I put the backend into maintenance mode again. Go back into my application, press save, again. 503, the request has failed. We'll wait a given period of time, and hopefully it will be retried again. We can look into payload. We see the post, this was the failed post request, and in the follow-up request, it's the same post, but this time successful. The other two batch requests are basically refreshing the list with the new data. The same also is available for a delete request. If I delete this entry now on the client, this time I give myself a little bit more time, let's say 30 seconds. Put into maintenance mode again, press save. The delete request has failed. Now I have to wait 30 seconds. I don't want to wait that long. Ain't nobody got time for that. So I reject. And suddenly, you see, the request is not repeated. The error is propagated to the message model, and I see my message pop over. Oh, yeah, didn't work. Okay, I quickly clean this up. I don't want to keep this entry in my database. This time, the backend was still not available, but for a shorter period of time, but it was retried automatically again, and it was successful. Now, you might ask yourself, that's a nice feature. How do I enable it for my application? Don't worry, we got you covered. First, I would like to explain the API. This is called the set retry after handler API, and it's available on all of our OData models, V2 and V4. It supports every request after the model's initialization. And what it basically does, it registers the callback function defined by you, the application developer, which is called in case a 503 error is returned by the backend and a corresponding retry after header is present. This callback function you define receives a parameter, retry after error, with two relevant properties. First, the message property, default with every error object, basically stating something like database is currently unavailable or services are currently unavailable. And the second property is the retry after property of type date. This is a timestamp which states when the backend is supposedly to be available again. Now, when using this API, there are certain prerequisites you need to consider. The first and foremost, Mathias already hinted at it, the backend has to return a retry after header in case of 503. Otherwise, we cannot determine when we may retry the request again. Secondly, the model or the defined callback function has to return a promise. This promise is basically the hook for our model to know when to retry the request again, which implicitly also means the promise has to be eventually be resolved or fulfilled, either rejected or resolved. If it's resolved, the retry happens again. If it's rejected, the retry doesn't happen. And lastly, we expect you, in case of a retry, to log the UI. As you might have seen in my post example in the demo, after the post was retried again, the data was loaded again, meaning in the meanwhile, if I would have made changes on the client, all changes would have been disappeared. This would lead to inconvenience for a user, therefore log the UI during the implementation, during the retry. Regarding the implementation, we have here a simple, a very abstract implementation of the API. As you can see, the first thing you want to do is retrieve your model one way or another. In my case, I retrieve the default model. Then call the API and provide a callback function with the parameter or retry after error. Then in the first section of my callback function, I prepare some stuff. For instance, I calculate the seconds until the retry may happen again. Oh, here the micro works. Okay, good to know. Sorry, I turn myself this way. And lastly, I return the promise. And in this promise, I define the process or the things which should happen while we wait for the retry to happen. And eventually, after the calculated period of time, I resolve my promise and optimally I close for a dialog or the message pop over, depending on what I defined in my executor of my promise. Now, before we want you to use this API, we would like to provide some guidance. These are not mandatory prerequisites, but rather recommendations you want to consider when using this API. The first and foremost are general recommendations in terms of when using this feature. You want to keep the process or handling of 503 consistent over all your models in your applications. If you have multiple models and one model behaves different in case of 503 than the other, one shows a dialog, the other one just locks the screen, it's inconsistent. You might want to keep it consistently for all models. Secondly, and that correlates with the first point, you want to register the same retry after handler for multiple models and optimally use the same promise. In case the first model runs into the retry after process first, and the second model sends another request, which would also run in retry after, you wouldn't want to show, for instance, two dialogues, 2 times the same dialogue. If already a promise is present, you want to reuse it, maybe. And the other point, we would like to provide some guidance regarding the waiting rules. The period of time, how long you have to wait for a retry to happen, may differ. And you might want to think about how I want to behave. The guidance we have applied in our demo, or the rules we have applied in our demo are the following. If the period of time for my retry to happen is lower or equal to 5 seconds, I just lock the screen, you see a busy indicator, and the retry happens automatically again. If the period of time I have to wait is between 5 seconds and 10 minutes, I will show a dialog with a progress indicator, as you have seen, and offer a reject button via which I can reject the promise and the retry doesn't happen. And lastly, if the period of time is longer than 10 minutes, I do not show the dialog, I don't want to wait that long, I immediately reject the promise and I'll be done with it. Now, before I go over to the next slide, I provide a lot of theoretical information and I would like to use the opportunity and showcase the actual code in my IDE for this retry after handler, how I would use this API. I make this a little bit bigger. I hope this is decent enough for you. I see pictures are taken. Bigger, okay, sorry. More? Say stop. Okay, perfect. So here I have the base controller class, which my application controller inherits from. And on this central point, I define a register retry after handler function, which basically does, as I recommended, always registers the same retry after handler. I retrieve the model for a given model name. If I don't provide a model name, I get the default model and call the retry after handler API. And here we have the abstract definition, which I provided in my slides. This is my preparation part. In the first part of the preparation, I use the retry after property of my error object to receive the timestamp or the time when the backend is supposed to be available again and calculate the retry after seconds. Then I define a function which I use to update the little progress indicator in my dialog. No big deal. And then I return my promise immediately. This is where I define what should happen if I run into a retry. Here we have the first waiting rule applied. If my retry after seconds are equal or below 5 seconds, set the view to busy and resolve after the given time. Then that's the third rule. If the seconds are over 600, meaning I wait longer than 10 minutes, reject and show a message with the error message. Something like database is currently unavailable. And if I run into the second time period, meaning between 5 seconds and 10 minutes, I start creating controls, which I would like to show. First the progress indicator, then I have a dialog with the corresponding content, properties, and here I define 2 buttons via which I can reject my promise. And in the end, I place this dialog on my view, use the previously defined function to update my progress indicator, open the dialog, and eventually, if no one pressed the reject button, I resolve my promise. With that, we are already at the end of our presentation. But before I go over to the Q&A, I would like to use the opportunity to remind you again about our expert models corners. If you have any questions related to any models topic, come around, have a chat with us. And now, with that, I go over to the Q&A. Do you have any questions regarding retry after? Give feedback, by the way.
Yeah, hi. Just a quick question regarding this retry after we get the parameter that we're getting from the failed batch call, right? So this has to be custom implemented in the backend, like CAPM service or anything.
As far as I know, yes.
No.
No?
Cup maybe.
Du bist an.
Just bin ich an. So Cup maybe yes, Rap no. With Rap you get it for free.
We get it, okay. But then like we don't have a set time when, like, the service will crash maybe for 5 minutes, 10 minutes, or maybe 5 seconds, right? How it's determined?
So how long it takes? I think this someone sets in the backend.
Okay.
So someone says, okay, this ABAP system is now not available for 5 minutes, and that's it.
Okay, thank you.
Hello. One question regarding the retry. I think in your case, always the backend system replies back, well, please retry in 10 seconds, 15 seconds, whatever. Is there a possibility, for example, in a logistics environment where the Wi-Fi coverage is not always the best, a big smile, to implement something like that, or there too with probably a message, well, please head over to a place with a better Wi-Fi coverage, because if someone is going through shelves, they're probably made of metal, Wi-Fi is not getting in quite good. So something like that, would that be possible with that solution too? Or is that not possible because there's no backend response to react on?
I think that's maybe the issue. Yeah? So we need to know how we can detect the situation. And if we don't know what's happening, then I think if you're having cases where you can say, okay, this is the specific behavior, what you see in the network top, what you get back, then we could, I think, do it. It shouldn't be too complicated. We would need to see on the failed request what happened. Yeah.
I implemented something quite similar, but just with a simple call that returns the same value over and over again. If I check the accessibility of my backend system, and if that's not accessible, I'll bring up a pop-up like that. But your solution or your approach looked a lot better, and a lot better.
I think the use case is a little bit different. In your scenario, you're talking about our crashed backend, but in our case, we are talking about an actively in maintenance backend. Somebody actively put it into maintenance, like I did in.
Sure. But for the user, whether the backend is unavailable or my Wi-Fi coverage is, or my Wi-Fi is broken, that is for some users it's quite the same.
Okay. Definitely, I think for users that don't know this stuff, it is the same. Yeah. I think we would need to discuss how we can detect that this is such a situation. In the end, we also shouldn't spam the backend, so we shouldn't create too many requests.
That's what I'm doing.
I think we are not allowed to do that.
Is your IP address already locked?
Yes.
Thank you. So what do you advise to do with the pending changes? Let's say that there was this example with deleting records. And what do you do if the user rejects? You clear the pending changes, or with the changes with the patch?
No, I think then we run into the normal mechanism like before. So I think for the delete, where Viktor showed it, it should be you just need to hit save again. Yeah. But there could be other cases where you are really in an error state. So maybe like when you scroll with your table and your paging request is then failing, I think then your application is broken. But it really depends on the concrete request.
Hi, just thank you for the presentation. Really cool implementation. I have a question in regards of how does the whole thing correspond to the concept of planned downtime and SLA, so the customers are aware of that the system is not available. How high is probability that they nevertheless are going to use it?
I'm not sure. I cannot comment on that.
Me neither.
So I think that's no one talked about SLAs to us. So we don't know what it really means for the SLAs.
You mentioned that the behavior should be uniform across different models, right?
Yes.
And let's say some services are returning the retry after time and some services are not. So in that case, can we default to something? I saw you are calculating the retry timeout seconds in that handler, right? So can we default if it is not available as, say, 10 seconds?
I think we really require this retry after header to be present. So if you have a backend that sends a 503 without a retry after header, then it will just be a normal failure. I think this point of you need to treat your models the same way, and ideally they have the same promise when they are in this state. This is something that came up during the implementation when we are thinking about what we are doing there. In the end, we also have, at least in some cases with OData V4, internal models, that you don't see as an application developer, where we need to take care to hand over the retry after handler, and to make sure it is in the end the same handler and then also the same promise. I think the point from our side is when we develop this, then there's always this point where you think about what could all go wrong. And I think if you don't block the UI, and if you're not using the same promise, then I think we cannot guarantee it really works. Because there were simply scenarios that we made up where we said, okay, it will be very complex to resolve this, but do we really need this? I mean, in the end, the UI should be blocked.
Thank you.
Well, thanks for the presentation first. I'm not sure if you can answer, but let's say I have an UI5 application running on BTP, connecting to a CAP backend or whatever. Do you know if, for instance, the CAP instance is unavailable, then there's no endpoint which can respond? Do you know of any mechanism on BTP or maybe the launchpads that can provide a mimicked response with a reply after header?
Viktor, if one of us knows such stuff, then
you. The specialty in our use case is even though the server is in maintenance, it still sends responses, which always are 503. You are describing a scenario where your CAP server is entirely gone? Or
but then maybe the platform can then provide a...
That's a question for BTP colleagues probably. Do they do they respond if the instances on their platform are not responsive? I have no idea.
Maybe take one more question.
Not everyone at once, please.
Yeah.